Welcome to this lesson on tetrahedral geometry. In chemistry, tetrahedral geometry is a fundamental molecular shape that you'll encounter frequently. It's characterized by a special bond angle of 109.5 degrees. This geometry creates three-dimensional pyramid-shaped molecules, with methane being the most famous example. Understanding this shape is crucial for predicting molecular properties and behavior. So what exactly is tetrahedral geometry? It's a molecular arrangement where one central atom forms bonds with four other atoms. These four atoms are positioned at the corners of a pyramid-like structure. Imagine a pyramid with a triangular base. That's essentially the shape we're talking about. The four bonds don't lie flat in a plane. Instead, they point outward in three-dimensional space toward the vertices of what we call a tetrahedron. The defining feature of tetrahedral geometry is its bond angle, 109.5 degrees. This is the angle formed between any two bonds extending from the central atom. Why is this angle so special? It represents the maximum possible separation between the four bonds. When bonds are spaced at this exact angle, they minimize repulsion between electron pairs, creating the most stable arrangement possible for four bonds around a central atom. Methane, with the chemical formula CH₄, is the perfect example of tetrahedral geometry. In this molecule, carbon serves as the central atom, and it's surrounded by four hydrogen atoms. Each hydrogen is positioned at one corner of the tetrahedron. The carbon-hydrogen bonds all point away from each other at that magic angle of 109.5 degrees, making methane a perfectly symmetric tetrahedral molecule. The reason behind the 109.5-degree angle lies in VSEPR theory. That's valence shell electron pair repulsion theory. This theory states that electron pairs around a central atom naturally repel each other because they're all negatively charged. To minimize this repulsion, the electron pairs arrange themselves to be as far apart as possible. For four bonds, the farthest apart they can get is at 109.5 degrees, which creates the tetrahedral shape. Tetrahedral geometry is associated with sp3 hybridization. Hybridization is the mixing of atomic orbitals to form new hybrid orbitals. In sp3 hybridization, one s orbital combines with three p orbitals from the central atom. This mixing produces four equivalent hybrid orbitals that are identical in shape and energy. These four sp3 hybrid orbitals then point toward the corners of a tetrahedron, ready to form bonds with other atoms. Methane isn't the only tetrahedral molecule. Carbon tetrachloride, CCl₄, has chlorine atoms instead of hydrogen, but maintains the same tetrahedral shape with 109.5-degree bond angles. The ammonium ion, NH4+, also shows perfect tetrahedral geometry. Silane, SiH₄, follows the same pattern with silicon as the central atom. Even the sulfate ion, SO₄²-, exhibits tetrahedral geometry around the central sulfur atom. Let's summarize the key points about tetrahedral geometry. First, it consists of four bonds arranged in a three-dimensional pyramid shape around a central atom. Second, the bond angle is always 109.5 degrees for perfect tetrahedral molecules. Third, this geometry results from sp3 hybridization and electron pair repulsion principles. Finally, many important molecules exhibit this geometry, including methane, carbon tetrachloride, and the ammonium ion. Understanding tetrahedral geometry is essential for predicting molecular shapes and chemical behavior.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.